Hey guys, hope you're all doing good and welcome to this video where I take you through the projects that you will work on in the course Data Structures and Algorithms. A good understanding of data structures and algorithms is a key skill that people look out for when they hire you. This knowledge helps the engineer to tackle a wide variety of problems that may arise. As the popular phrase goes, practice makes perfect, which is what we follow here. This course essentially develops your problem-solving skills by taking you through around 50 problems, out of which 30 will be considered as part of your projects in the course. The other 20 will be worked on as part of the assignment for each week. The objective of designing these particular set of problems or projects is to equip the student with the skills to solve any problem in the most optimized manner for any web applications that they may create. These problems will help them solve pretty much any question regarding data structures and algorithms that a company usually asks, and helps the student make themselves a better full-stack engineer. The first concept that you will learn in this course is the array. An array is used to store multiple values in a single variable. Regarding arrays, you will be given two problems to solve. The first one is to find the equilibrium point of an array consisting of positive numbers. This means that you have to find the number in the array such that the sum of numbers before it is equal to the sum of numbers after it. The second problem concerning arrays is to find the leader in an array. Here you need to print the largest number when compared to the characters to the right side. The next concept that you will learn is strings. A string is the sequence of characters which can, for example, store the word hello. You'll be given two tasks to test your knowledge on the use of strings. First, you'll have to reverse the whole string without reversing the words in it. The next task is to take a string and output the string without any duplicate characters. A linked list is a type of data structure where the elements have a separate data part and an address part. Here, you'll use linked lists to identify the middle element, and then you will have to reverse another linked list. The next concept that you will learn under the data structure part of this course is the concept of trees. A tree is a data structure where the objects are arranged in hierarchical relationships. Regarding this concept, you will be required to convert this binary tree to a DLL, which is also known as a doubly linked list. Regarding the data structure called as graph, you will be required to identify the minimum number of swaps to sort the array into a non-decreasing order. Next, we have the stack, which is a data structure that is based on the last in first out approach. Then we have a queue, which is based on the first in first out approach. Using both these data structures, you are tasked with getting the minimum element out of the stack within a time complexity that will be specified. With that, we come to the end of the minor projects that you will be encountering in this course. Next, we have the major projects, of which the objective is to provide you with a set of 20 problems to be solved in an optimized way within the given restrictions of time and space complexities. We will cover the concept of arrays and strings again within the major project. First, you will be required to obtain a sub-array from the given array, which leads to a given sum of 12. Here 1 and 3 is the index notation for the array. For example, the index notation of 1 is the number 2 and the index notation 3 is the number 7. So the sum of elements between 2 and 7 leads to the sum of 12. The next project is to find all the permutations of a given string of characters and print them out in an alphabetical order. We will then cover two more projects on trees. The first project that covers this topic is to identify the number of leaves in a binary tree. The next project is to find the lowest common ancestor in a binary tree. The goal is to find the last node that has two common parent nodes as N1 and N2, for example. Sorting is the next concept that we will cover in the major projects. Here you will have to sort a linked list containing zeros, ones, and twos and segregate them. Searching is an important function that is employed in various websites. Identifying the correct search methods is crucial. In the next project, you will be required to find the first repeated character in a given string and then display it. The next project using the concept of searching requires you to create a function that will help determine if two arrays are equal or not. Hashing is the next concept that you will be tested on. Hashing converts one value to another and is used mainly for authentication purposes. Here you are required to sort two arrays of different sizes in relation to each other. So the first array is to be made in the order of the second array. So the objective is to make all the number 2 in the first array to be before 1. And all the number 1s should be before number 8. And all the 8 should be before 3. Since we have the number 2, 1 and 8 occurring twice in the first array, the output will be printed in the form 2, 2, 1, 1, 8, 8, 3. And since 5, 6, 7 and 9 does not appear in the second array for reference, it will be displayed last. This covers the relative sorting part. We have 3 more projects on graphs, where the first one is to identify the shortest path between two coordinates in a 2D matrix. The first input arguments will be the size of the matrix along with the elements and then the required coordinate. The objective is to print the minimum number of steps required to reach the destination coordinate. We then have the task to find the minimum cost path in a 2D matrix with each cell having a particular cost assigned to it through integers. The next project under the section of graphs is to identify if two strings can form a circle. To identify that, the last character of one string must be the same as the first character of the other string. We then move on to cover projects on greedy algorithms and the divide and conquer approach. The divide and conquer approach contains additional concepts that you will be tested on. They are the two-pointer and sliding window method, and then the bit manipulation method. Under greedy algorithm, you have the first project where the task is to find the order in which a meeting can take place according to time constraints. The input arrays contain the starting and ending time of each meeting I of the array. Next, we have two arrays A and B. The objective is to find the minimum sum of products of the elements of the two arrays. That is, you multiply each element of the array and take the sum of the products. You can also shuffle the elements of the array to find the minimum value. Here, after shuffling, the minimum value is found to be 23. The third project under greedy algorithm concept is to find the largest number possible out of a two-input argument. Now, what are the input arguments? Well, the first argument n is the number of digits, and the sum of these digits must be equal to the second argument s. After this, we have the projects coming up using the divide and conquer approach. You will be given a sorted array with the elements that are repeating. The task is to find the element that appears only once in the array. Here the element 4 is the only one that is not repeating. Next, under the divide and conquer approach, we have 3 important concepts. The two-pointer method uses 2 pointers to compare 2 elements, which can be numbers, strings, etc. The sliding window is an approach for searching the required element. Using these 2 methods, you are required to find the length of the longest substring, which contains distinct characters only in a given string. Then the next task is using 2 strings. You will need to find the smallest window within the first string, which contains the characters in the second string in no particular order. Now, using the bit manipulation approach, you are required to find out if a particular input integer n can be represented as a power of 2. 1 can be represented as 2 raised to 0, so the output will be printed as yes. 98 cannot be represented as a power of 2. So the output will be printed as no. After this, we move on to the concept of stacks and queues. We have the task of finding the first non-repeating character in a given stream. If no non-repeating characters are found, they are to be substituted by -1. Using heaps, the student is then required to find out if a given string can be arranged in such a manner that no 2 adjacent characters are the same. If no such arrangement can be made, then it will print a value of 0. Dynamic programming is an optimization algorithm. You are given 3 projects to complete using dynamic programming. The first one requires you to find the longest common subsequence in the given strings. I don't have an image to represent it here right now. The second project requires you to find the subsequence of increasing elements, which gives you the largest value. For example, 1 and 101 is an increasing sequence. 1, 2, 3 and 100 is another increasing subsequence. Similarly, 1, 2, 3, 4, 5 is another subsequence. You need to find the sequence which will give the largest sum. The last project in this course tasks you with finding the number of hops that a frog can take while jumping from one level to another. If you have only one level, the frog can take only one hop. If you have 5 levels, the frog can jump from 1 to 2 to 4 to 3 and at the end reach the top level. Similarly, there are other ways to find the number of hops. Your objective is to use dynamic programming to find out the correct number. With this, we have covered all the projects that you will be working on in the course Data Structures and Algorithms. Most of these questions are regularly asked in interviews in various companies, and this will definitely help you tackle them effectively. Thank you for watching.